You are welcome back to my YouTube channel. I am Moses Oluwasegun, and this is Programmed Mathematics. In the last video, I explained the use of matrix method to solve problems of simultaneous equation in both 2 variables and in 3 variables. So in this video, I will be explaining how to use the Cramer's rule, okay, to solve problem of simultaneous equation. Now, Cramer's rule is also part of matrix. The only difference here is that it strictly uses determinants to solve problems involving simultaneous equation or a system of equations. Okay, so in this case, all we need to do is calculating the determinant of given matrices. All right, so after forming the equation into a matrix, we make use of the determinant, okay, of the matrix to solve the problem. So let's take an example on this. As an example, we want to solve the equation using Cramer's rule. Okay, so Cramer's rule to solve the problem. So let's say the problem we have is 4x minus 5y equals 7 and 3x plus 2y equals minus 11. Okay, so now all we need to do, like I said, is determinant. So we translate this problem into a matrix. So this one to a matrix first. We get the matrix of the coefficients of x and y of x first in the 2 equations. We have 4, 3. So we have 4, 3 here. Okay, then the coefficients of y, minus 5 and 2. Minus 5 and 2. Then the matrix of the variables. X comes first, follows after by y. So in this case here, x comes first, then y comes next. So this is equal to, this is 7 minus 11. Okay, so once we have done this, let's call this one maybe data A. I mean the matrix A, matrix X like usual, then the matrix B. All right, so this, just for recognition's sake, this matrix A, I'm calling this one matrix B. All right, so how then do we do this? We need to find the determinant of matrix A. Once we know the determinant of matrix A, we find the determinant corresponding to X. Once we have done that, we also find the determinant corresponding to Y. So the determinant of X corresponding to X, we divide it by the determinant of this matrix of the coefficients. The determinant corresponding to y will be divided by determinant of this matrix of coefficient, and that'll be all. Okay, so let's find the determinant of the original matrix A. So determinant of matrix A, we can write that as this. You can decide as well to use data naught as this to represent the determinant of this matrix of coefficients. Okay, so in this case here, determinant of matrix A simply means determinant of 4 minus 5, 3, and 2. So if we calculate this determinant here, 4 times 2 is 8, minus 3 times minus 5, that's minus 15. So this is 8 minus times minus is plus, so we just change that to plus. 8 plus 15 is 23. Okay, now the next thing we do is we find the determinant corresponding to the variable x. Now, to do that here, first thing we need to form the matrix corresponding to x. So all we need to do is this x column, okay, remove this x column and replace with this matrix here, the matrix B. This x column here, remove it and replace with 7 minus 11. So when we want to find the determinant corresponding to x, so we simply mean we are calculating the determinant of, so this x column now will now become 7 minus 11, and the y column, okay, still stays the way it is because our focus is not on y yet. So y column still remains the way it is, that's minus 5 and 2. So we calculate the determinant of this as well. Okay, so this will give us 7 times 2, which is 14. Okay, minus 5 times minus 11, that is 55. Okay, that's plus 55. So 14 minus 55. Okay, 5 minus 4 is 1. 5 minus 1 is 4. So this is minus 41. Okay, then for delta y, we do the same thing for delta y. But in the case of delta y, we need to replace the y column. So we remove this from x now. So we go to the y column. This is y column here. Okay, we replace the y column with this column here. And so that means we calculate determinant of 4, 3, then minus, that's 7, minus 11. So if we calculate the determinant of this as well, 4 times minus 11 is minus 44, minus 7 times 3 is 21. So together here, this will give us minus 65. Okay, so now we have the three determinants we need. Determinant of the matrix of the coefficients, the determinant corresponding to x, that is this, then the determinant corresponding to y, that is this. Okay, so then the next thing we do is we calculate the values of x and y simply by dividing. Okay, so let's find the values of x and y. So x value will be the determinant corresponding to x divided by the determinant of the matrix of the coefficients, okay, which is the theta A there. The same thing for y, determinant corresponding to y divided by determinant of the matrix of the coefficients. And so for delta x, we have minus 41 over delta A, which is 23. And for y, we have delta y minus 65 divided by delta A, which is 23. And that gives us the solution to the simultaneous equation. Now, you can cross-check this, like I usually say, when you solve an equation, as so long as an equation, you can cross-check your answer. Whether a teacher is there or not, you can be very sure that what you have done is correct or wrong. So in this case here, the first equation says 4x minus 5y is equal to 7. That's the first equation. So all you need to do, bring in the value of x and y here. If you get 7 at the end here, then it shows what you have done is correct. So let's check that here. Okay, you can pause the video and check that yourself as well. 4 times minus 41 is minus 16.4 over 23. Minus 5 times minus 65. That's a minus, that's plus 325 over 23. So if we simplify this, 5 minus 1 minus 4 is 1. 12 minus 6 is 2. 2 minus 1 is 1 over 23. Okay, so this here should give us, if we divide this here now, okay, can we get 7 here? If we multiply this by 7, okay, that give us 7. That's okay, sorry, this is 6 here, so this will give us 7. Okay, so 7 times 3 is 1. That's 21. Then 7 times 2 is 14 plus 2. That's 161. So 161 divided by 23 is 7. You can do the second one also for the second equation. Second equation says 3x plus 2y. That one is minus 11. So 3 times minus 41 is minus 123 over 23 plus 2 times minus 65. That's minus 130 over 23. So if we simplify this, this will give us 1, this is 2 and 3, that is 5, and this is 3, so that's minus 253 over 23. Okay, if you divide this here now, 23 in 25 is 1, remaining 2. 23 in 23 again is 1, so this minus 11, which is correct. All right, so you can do this also every time you solve an equation. You can be very sure that your answer is correct. Okay, now once we have that, what if you are given a 3 by 3 equation, that is a simultaneous equation in 3 variables? Okay, so let's take that as another example. Okay, another example here. Let's call this one example number 2. The first one is example 1. So we want to solve the equation. Solve the equation using Cramer's rule. Okay, so you can pause the video. Now you know how to find determinant of a matrix. So you can pause the video and practice this also on your own first. So using Cramer's rule, we want to have 2x minus y plus z. Okay, let's say this one is equal to 1. Okay, then x plus y plus z. Okay, let's say this is let's just say 2 or 3. Let's say 3 here. Okay, we have that to be 3. Then x minus y plus minus z. X minus y minus z. Let's assume this is what we have in that case. Okay, so this is minus 1. Okay, so you can pause the video like I said and solve this question yourself first. Now to solve this problem here, okay, so first we translate the problem, the equation, into the matrix form. So we have the solution to that. So the coefficient of x, we have 2, 1, 1. 2, 1, 1. Then for y, minus 1 plus 1 minus 1. Minus 1 plus 1 minus 1. For z, plus 1 plus 1 minus 1. Plus 1, that's the same thing as 1. Plus 1 plus 1 minus 1. Then the variables x, y, z in that order. X, y, z. And then the result on the after the equal to 1, 3 minus 1, 3 minus 1. Okay, so the usual approach, we call this one data A. Okay, that the matrix of the variables and then the results. So we can call this one the matrix B. Anyway, we are not majorly focusing on the labels. So just for identification, so data A now will mean the determinant of this matrix 2, 1, 1, minus 1, 1, minus 1, 1, 1, 1, 1, 1, minus 1. Okay, so if I'm using the first row or I'm using the second row for the calculation, this is minus, plus, minus. So I'm going to have minus 1 multiplied by, let's do this straight, minus 1, delete the row and the column 1 belongs. So 1, we have this and this deleted. So minus 1, 1, minus 1, 1. Minus 1 times minus 1 is 1. Minus 1 times minus 1 is minus 1. Okay, then plus 1 into, delete the row and the column 2. 2, 1, 1, minus 1. 2, 1, 1, minus 1. So 2 times minus 1 is minus 2. Minus 1 times 1 is 1. Then plus, okay, minus, plus, minus. So the next sign there is minus 1, bracket. So for this one here, we delete the row and the column as well. Row and column. So we are left with 2, minus 1, 1, minus 2. So 2 times minus 2 is minus 2. 1 times minus 1 is minus 1. So this is minus, minus 1. Okay, so minus 1 into 1, minus times minus is plus. So this is plus 2. 2 plus 1, bracket, minus 3, minus 1, bracket, minus times minus is plus. Minus 2 plus 1 is minus 1. So if we simplify this, finally this is minus 2, minus 3, plus 1. Minus 2 minus 3 is minus 5. Minus 5 plus 1, that's minus 4. So the determinant of the matrix of the coefficient is minus 4. So let's get the determinant corresponding to x, y, and z. Okay, x, y, and z in this case. So for data x, we are calculating the determinant of, don't forget the approach, this is x column, replace with this. So we have 1, 3, minus 1, minus 1, 1, minus 1, 1, 1, minus 1. Okay, so you can use any of these as well, any of the rows, to find the determinant. So I'm taking row 1. If I'm taking row 1, I have plus, minus, plus. So 1, in this case, bracket, I'll be left with 1 times minus 1 is minus 1. Minus 1 times 1 is minus 1. So this minus 1. Then minus the sign convention, the minus 1 itself. Okay, bracket. So this row and column deleted. 3 times minus 1 is minus 3. Minus 1 times 1 is minus 1. So this is minus 1. Then for the last one here, 1. That's positive plus 1 bracket. Delete the row and column. 3 times minus 1 is minus 3. Okay, then minus 1 times 1 is minus 1. So this is minus 1. So simplify this one straight. Minus times minus here is plus. Okay, so minus 1 plus 1 is 0. So automatically this one here is 1 bracket 0. Okay, then plus 1 bracket. Minus 1 times minus times minus is plus. Minus 3 plus 1 is minus 2. So this is minus 2. Then plus 1. Minus times minus is plus. So minus 3 plus 1, minus 2 again. So 0, minus 2, minus 2. So this is minus 4. Then do the same thing for data y. The determinant corresponding to y, the y column will be removed and replaced with this. So we have determinant of 2, 1, 1. Then 1, 3, minus 1, 1, 1, minus 1. So determinant of this as well, using row 1, plus, minus, plus. So for 2, we have 2 brackets. The determinant here, 3 times minus 1 is minus 3. Minus 1 times 1 is minus 1. So this is minus, minus. Okay. Minus 3 plus 1, that's minus 2. Then minus 1 bracket. Delete the row and the column. 1 times minus 1 is minus 1. 1 times 1 is 1. So minus 1 minus 1, that's minus 2. Then plus 1 for this. We delete that. 1 times minus 1 is minus 1. 3 times 3. 1 times 3 is 3. So that's minus 4 together. So if we simplify this minus 4 plus 2 minus 4. Okay. So minus 4 is minus 8. Minus 8 plus 2 is plus 6. Minus 8 plus 2 minus 6. Okay. So then the last part of it, okay, is to find the determinant corresponding to z. So what I'm going to do here, let me just modify this. Okay. So I'm going to replace the z column with this so that we can then have, let me transfer this down here. 2 minus 1, 1, 1, 1, 1, 1, minus 1, minus 1. Okay. So for data z now, for data z, so we're going to have determinant of 2, 1, 1, minus 1, 1, minus 1. So this will come in now 1, 3, minus 1. Okay. So this one here is data A. I'm going to clean this part here. So you can do the calculation of this as well yourself. So 2 multiply, delete the row and column. 1 times minus 1 is minus 1. Minus 1 times 3 is minus 1. So this minus 3. Minus 1 times 3, minus 3. So minus. So that's minus 1 plus 3. That's plus 2. Plus 2 here. Okay, I'm taking the first row as well. Plus, minus, plus. So this is minus 1 into the row and column deleted. 1 times minus 1 is minus 1. 1 times 3 is minus 3. That's minus 4. And then plus 1 into row, column deleted. 1 times minus 1 is minus 1. 1 times 1 is 1. So that's minus 2. Okay, so once we have that, then we simplify. This is 4. Minus times minus is plus. Plus times minus 4, that's minus 4. Plus 1 times minus 2 is minus 2. So this is going to be equal to minus 2. So we have the determinant corresponding to x, y, and z. So in this case, to find x, we divide delta x by delta a. Y is delta y over delta a. Okay. Z is the same, delta z over delta a. So delta a is minus 4. Okay, delta a is minus 4. So we have delta z, delta x here is minus 4. So minus 4 over minus 4. Then y, delta y is minus 6. Minus 6 over minus 4. And delta z for z is minus 2. So this one here is equal to minus 6 over minus 4. This one is minus 2 over minus 4. So if we simplify this, this is 1. Y here will give us minus going out from here. 2 here is 2. 2. Then 2 here is 3. So this is 3 over 2. And of course, minus cancel from here. 2 here is 1. 2 here is 2. We have 1 over 2. So x equals 1. Y equals 3 over 2. Z equals 1 over 2. So if you want to cross-check that, okay, you can do that using the first equation. Okay, so don't forget the first equation, we are supposed to have 1, 3, minus 1 as a final answer. So for x here, this is 2x. 2x. X is 1. So 2 times 1 is 2. Then minus y. Y is 3 over 2. That's minus 1.5. Then plus 1z plus z. Z is 0.5. If we cross-check that, minus 1.5 plus 0.5 or 2 minus 1.5 is 0.5. 0.5 plus 0.5 will give us 1 here. Then if we check the second equation, we are going to get 3. So for second equation, we have 1 plus, that's 1x plus y plus z. X is 2. X is 1 here. 1 plus 3.5, that's 2.5. 2.5 plus 0.5, that will give us 3. So that shows we are right. But make sure you do that also for the last one. 1 is x, that's 1 plus minus y. Y is 3 over 2. So 1 minus 1.5, then minus 0.5. 1 minus 1.5, that's minus 0.5. Minus 0.5 minus 0.5 will give us minus 1, which is this. So it shows that the values you have for x, y, and z are very correct. So whenever you solve an equation and you cross-check your results and you're not getting the same thing as the original equation, as what you have initially, okay, it shows that what you have done is wrong. So whether a teacher is there or a teacher is not there, you can be very sure that your equation is right or the answers you have gotten for your equation are correct. Okay, so this brings me to the concluding part of matrix. Now, matrix is a full playlist starting from the definition of matrix, types of matrices, the reference elements of a matrix, matrix operations like addition, subtraction, multiplication, scalar multiplication, from there to determinants of a matrix 2 by 2, 3 by 3, to cofactors, adjoint, transpose, and all of them. So please, in case you have missed out any of this, you can help yourself with the full playlist, okay, that will help you to have proper understanding of everything about matrix here. Now, for this level of secondary education at the college level, we stop here. But that does not mean this is the last part of matrix, okay? There are other advanced aspects of it as we're talking about the echelon row operation on matrices. We talk about Gaussian elimination method of solving system of equation, okay? You have several aspects also that can be discussed at the advanced level. With this, you should not have any problem handling questions on matrices. Okay, so in another separate video meant for those at the university level, okay, I'll be taking this matrix beyond this level. So for now, I'm going to leave it here. So please, if this is your first time of coming in contact with this YouTube channel, please subscribe, like the video, share the videos, and at the same time recommend the channel to everyone around you. Please don't forget to subscribe. Your subscription is very important to me. Okay, the thumbs up on the video, your comments are all very much important to me. So please do this and let's work together so as to make life comfortable for both me and every other person who have access to this. All right, so please help yourself with the videos and get your answers strong on matrices. Okay, so this is programmed mathematics, and I am Moses Oluwasegun Walex. Thank you.